I think we're going to start. Welcome to my talk about web development with Java at the end. I'm Simon, and I work in the industry for already a very long time. I started in 1995 with COBOL and mainframe computers and moved in year 2000 to Java. I'm teaching at the university in Bern. I have my own company since 13 years, and I'm very active in the Java community in Switzerland. I'm organizing Java user group events, so if someone of you is in Bern, maybe, so give me a call and then we can organize a talk if you like to. I'm also in Java specification requests, Java batch, money and currency, and this already may indicate that I'm not a front-end guy, right? So I'm a Java developer, I'm a back-end developer. Here with COBOL, I was mainly working with SQL databases, and I'm still working with SQL databases. But now I'm using Vaadin, and this was kind of a coincidence, and I was talking a lot about Vaadin recently. That's why I get the Vaadin Community Award last year. I'd like to talk to you about the current project. So I'm working now for 3 years in a project. It's an ERP system. It's an ERP product that companies in Switzerland are using, more small or medium businesses, because the big companies all use SAP. So there's no chance to get into that market, but there are a lot of small businesses that can use that. And this ERP system is a traditional database-driven application. So the product, the core of the product is already 35 years old, and it still uses the same database schema, more or less. So it's an Oracle Forms application. Does anybody know Oracle Forms still? So today we have Apex, so that's more or less the same ID, but not the same whatever. And here we have some numbers. The application has 800 forms, so a form is like a screen where the user enters data. We have around 2,000 tables and views, and all the business logic is inside the database. So we have PL SQL, functions, packages, procedures, and these are around 5,000. And then there are some user-defined types, but that's not really interesting. The point is, the ERP system is a product. So if you want to sell a product, you have to make it in a way that the customer can adapt it. Maybe they want to change how the UI looks, or where the fields are, or maybe they want to add additional tables to store special data. And that's more or less one of the issues that we had. And the goal of the project was to build a modern web front end. Now, I was not in the project from the beginning, because first the client tried to use something similar to Oracle Forms. So they were looking for low-code, no-code tools that they can generate more or less the UI. Yeah? That was the idea. And, but this didn't turn out so well. So you know, maybe this low-code, no-code stuff is already very old, and it's always the same. It's an 80-20 product. So 80% of the requirements are easy to use or to cover, but the rest is very hard, and you will have to work around the tool and stuff. And this relatively started soon in the project, and so they were looking for kind of a different solution. And that's where, when I came in, because the idea was that I will help them to find out how to use this low-code tool in a better way. I didn't know the low-code tool, but it was quite interesting because it used internally Vaadin. So you could create a UI with the tool in like a meta UI framework, and then you can generate Swing or Vaadin. And I was looking at Vaadin. I was not an expert, or I didn't even use Vaadin before, really, just for some Hello World projects, but not in production. And I thought, hey, Vaadin sounds interesting. And then we decided to do a prototype with Vaadin to see if it can do similar like the low-code tool does, but in a customized solution. And here we have the goal. So if you've never seen Forms, this looks like this. So it's AWT, Swing, whatever, and it's generated and then delivered with WebStart. So that's another issue, because WebStart no longer part of the JDK. And this is now the current state, more or less, of the application that we have. It looks quite similar, you see. So it's an ERP system. No surprise, we have a lot of tables here and the form that you can enter the data, and more or less all the 800 forms looks similar. Some are more complex, some are less complex, but the style is always the same. Now, what we had to do is to make the UI customizable, we had to add something like a UI editor. So we don't have a graphical one yet, but we have a tree. So this tree that you see here is the component tree. So you create a model like the product management UI, and then you say that's a product management module that's here on top. And then you can add tabs, and here we have like a form with components like text fields, checkboxes, buttons, stuff like that. And you can define that now in our application in the database. So this is stored in the database. And the mechanism that we have here is when the user hits a module, then the data from the database is fetched, and we create the UI at runtime. So we don't generate it, that's not the right word, but we read the data and we present the created UI to the user. And so every user has his own UI, because we also have like authorization stuff in the database, data that's maybe not could not be visible to some of the rows, or we have fields that get read only if you have, or you're missing some rows or stuff like that. So everything is created in the database, and then the framework that I created with Vaadin at the end reads the data and creates a Vaadin UI. So that's how this works. Now, before we get into Vaadin, I like to talk to you about UI frameworks, because that's very important when we talk about Vaadin, because Vaadin is a bit different. We see that here. Maybe someone was at the talk from Wim yesterday. He was talking about Timeleaf, HTMX, and we also have JSF. Maybe someone is still using JSF. I have customers that are still using JSF, and that's classical server-side rendering like ES4. So the traditional page lifecycle is you do a request, and then you get back an HTML page. On the other hand, we have these classical single-page applications, like if you use React, Angular, Vue, Svelte, whatever framework you would use. And there's different lifecycle. You also do a request on the server, but you get back a so-called shell, or UI shell, or app shell, or whatever you want to call it. And this doesn't contain anything, HTML, but it contains a lot of JavaScript, or it references JavaScript, and then the client is using this JavaScript, or the browser is using this JavaScript to create the UI. And then all further requests will be AJAX requests, where you just get the data, and then you do the UI on the client side. And interestingly, Vaadin is a single-page application framework, because it has exactly the same mechanism, but we as a developer, or I as a Java developer, I don't see anything of that. I only see that if I have issues, and every framework has issues, and then you may have to have a look at the browser and see what happens there, but usually you don't do that. Another thing to mention is state. Because if you do traditional applications, you often have state. So you have session state, you want to store something in the session. And that's also a reason why these types of applications maybe become less popular, because everybody's using Kubernetes, and Kubernetes stops pods, starts new pods, and that's not good for state. If you look at the single-page application lifecycle, there you usually have the state on the client, but not with Vaadin. Vaadin has state on the client and on the server. And the reason for that is the architecture. So I go here. If you have a look at the architecture of Vaadin, we have an application server. So usually that's Spring Boot. That's why I'm talking here, because the usual framework that you use together with Vaadin is Spring Boot, but you could also use Quarkus, Micronaut, it doesn't really matter, or any application server. And there you have the Vaadin application. And the Vaadin application is your user interface code, plus you use components. And the components in Vaadin are all web components. And we will see that later on. You can have also HTML templates if you want to do a declarative programming model. I don't recommend that usually. And you have themes with custom CSS where you can style the application. So that's the server side. And on the client side, you have the same. So here we have the web components, the HTML templates, and the theme. They get delivered with the first request. And then you have a communication in both directions sometimes. So every time you click on a button, for example, this will be propagated to the server. And if you, on the server side, have user interface code and do a button click, then the button click is sent to the client. So that's how Vaadin works internally. It's no longer the same as before, so we can go back to the history. Vaadin is even older than Spring. So they started in 2001, more than 20 years ago. But I think around the year 2007 to 2010, it was very popular. But then it uses JWT. JWT still exists, but it's no longer maintained by Google. Google stopped working on JWT, probably because of Angular. And Vaadin was looking for a different way to build applications. And that's where web components came in. Who knows what web components are? Okay, web components, I will show you in the browser in a minute. Web components is a way to extend standard HTML. So you have standard HTML tags like you have an input, you have H1, you have a paragraph, you have an anchor, stuff like that. And with web components, you can create your own text field or your own table or whatever. And there's a specification, so you have some template, you have some JavaScript code, and that makes a web component. And for that purpose, you usually use Polymer. Polymer is also from Google. That's a web component framework, but this is in maintenance mode now. And Google recreated the framework, and it's now called Lit or Lit Element, depending on which version you're looking. So Vaadin is based on Lit now. Most of the components are still Polymer, but they're currently working on the transition to the new web component framework. And exactly at that time, in 2019, where the framework was recreated, I came into the project, so I'm using the new version of Vaadin. I don't know much about the old GW2-based version. I just know that currently a lot of companies are trying to migrate from the old Vaadin to the new Vaadin version, so that's not so easy sometimes. Most of the time it's not, but not that hard. So currently we are in 2020, and you see between 19 and 22 there were 13 versions. So that looks a bit odd, right? But that's just because of the numbering schema that they used for the versions. It doesn't have to say something. The latest long-term support version is 23, but they get away from this model, so they don't have this long-term support stuff now. They support most of the major versions the same amount of time, so it doesn't really matter. Maybe someone of you was yesterday at the talk from Manula. He's from Vaadin, he's working in Madrid, and there's a framework, Hilla. Hilla uses also web components, uses Lit Element, and is kind of a product that just came out of the rework of Vaadin. So this is a real single-page application framework without server state, but I will not go into that. So now the question is, why do we want to use Vaadin? I think the most important reason for that is because we are Java developers. It is not only the API that is great, but if you have an Angular or a React application and you do full stack development, who does full stack development? Do we have any front-end developers here? And if you separate that, and that's also a thing that happened in the last, I would say, 10 years. Before, we were all full-stack developers. So with JSF, with Timeleaf, with Swing, Eclipse RCP, stuff like that. Every developer was working on the client and on the server mostly. And with these types of frameworks like Angular and React, there was a split. So the development team is split into front-end and back-end developers. And if you're now trying to do full-stack development with these frameworks, you have two builds. So you have to care about all the JavaScript build with Webpack or Vite or whatever you're using, and you have to take care about the build with Maven, Gradle, whatever. So we have two moving parts maybe, and that's a bit hard. And this is something that you don't have. Under the hood, Vaadin uses also NPM or PNPM and Webpack or Vite, whatever you want to configure, but you don't see it and you don't have to touch it. That's the main reason for that. On the other hand, what's great with Vaadin is the rich component model. You have many of really good looking and great working components. So you can go here. And Vaadin has something that's called a design system. So design system is, I would say it's a relatively new term. In all older days, you were maybe talking about corporate identity or corporate design. Now it's a design system that has everything. So from the look and feel to the components, how they behave, that's all in this design system. And so you have themes that are prepared currently. Lumo is the default theme, but you also have a material theme, for example, and you have these components. And they are all web components. That means you can also use the same components in other applications, because the components are not bound to Vaadin. The only thing that is bound to Vaadin is the Java API, but the web component can be used in a React or Angular application, or in a lit element application, or in a pure vanilla, plain vanilla JavaScript application. That doesn't matter. So that's very helpful, because the components, and that's a bit special, are made for exactly this type of application that I've shown you before. So that means we have grids, or 3 grids, and they have data providers. We will see that in a minute. They allow us paging, sorting, and filtering. Out of the box, you don't have to do much. We have forms with bidirectional data binding, with validation and converters. So everything that you usually need to create a data-centric business application is just there. So that saves a lot of time. I would say if you have to do the same thing with Angular, it takes much more time. So I would say like 25% you spend more if you use another framework. Plus, and that's the most important part, you don't need a REST API. Because if you're doing single-page applications, you have 3 parts. You have the UI, the REST API, and the backend. And you have to test all of them. With Vaadin, you have only 2. So you have the front end and the back-end code. You can split that. You can keep that together. You can even, and I will show you that later in the demo, you can even use repositories or call directly SQL statements in the UI if you like to. Because sometimes you have like a master data management application and you don't need all the layers in between the database and the UI. So maybe you can bind that together already. So it's a great fit, in my opinion, for these types of applications. Now let's have a look at some code first. That's a view. So the view is like a page in your application. And what we see here in the constructor of this class, we have a text field, a label, and a button. So that looks like Swing, right? So everybody who has working with Swing or AWT feels familiar with them. We have labels. We can add the click listener here. This lambda expression there is the click listener. And at the end, we add the fields to that layout. So we have layouts like we had with Swing, grid bag layout, whatever. Here's vertical layout or any other layouts. And this we can see in the application. So the question is, how do you start with Vaadin? You can go to start.vaadin.com, like Josh with start.spring.io. We have the same here, but it's different because what you have here is kind of mock creator or whatever you name it, you can add here, for example, a master detail view. And then you have already some data. You have the database connection inside. You have here it uses JPA, but you can use anything else, and this just works. So you can download the application. There are settings. For example, you can create or you can add security. So this will use Spring Security, and you can download that, and you're done. Then you have to write the code for sure, but you have like a template that you can use and work further on the template. You don't have to do everything from scratch. That's very helpful. And I did that for you, and I created this Hello World application. And the contrast here is not very good on the Beamer. Here we have a text field, and here I can enter some code and say hello, and this does it. Now the question is, what happens if I do that? And that's quite interesting. First, we may have a look at the application itself. And what we see here, we really don't have any HTML. But if we inspect the DOM, we see there's a div with an outlet. So that's the starting point where our code will be inserted. And then we see, if we go inside that, we have the vertical layout. Here we have a form. And in this form, then finally we find the text field, the button, and somewhere else will be the label. And that's what I thought about web components. So as you can see, these are Vaadin form layout, Vaadin text field, stuff like that. And that's a web component. And the web component has to have a prefix with a dash. Otherwise, it's rejected because it could have a collision with a regular HTML component. And what's special with these web components is they have a so-called shadow root. The shadow root is used like a sandbox that you don't see the internals of the web components, and you are not able to access the internal of the web component. But that's very important because the styling then looks a bit different as what you do for a regular HTML component. So that's how the application looks like. Now the question is what's happening, and let me reload the page and clean the output. Now do the same again, like that. And now we have requests, and here we have two requests. These are post requests, similar to JSF. People remember maybe JSF, there was everything a post request. But this one is different because what we have here is, if you look at what's sent to the server, here we have, it's called RPC node, so it's kind of a JSON what's sent. But we see that the property value Barcelona is sent to the server. So for every click, or even it depends how the text field is configured, you can have different models. So you can have a lazy model, that's the normal one. So if you type, it doesn't do for every click on the keyboard requests, but it waits some time, and if you stop typing, then it will send it to the server. But you also can have eager, and then every hit on the keyboard will be sent to the server. So that's how Vaadin works internally. That's normally not that important because usually this works. But if you, for example, have to style the web components, then you have to have a look at the DOM sometimes to find out what element do you really need to change. Now for people that know the old Vaadin version, the GWT one, then they know that it wasn't really a web application. And that's something that changed. And Vaadin introduced the concept of routes. So now every URL that you enter in the browser is a real URL. And you can get that also inside your application code. You can override the setParameter method, and you get the parameter, so the location. And in the location, you can get the query parameters. So that means everything's bookmarkable. You can use that as links, and this can be processed. And you also can change the location address and also the query parameters from your Java code. Now, the most important or the most interesting part of the Vaadin components, in my opinion, and the most complex component at all, is the grid. Because it has all the stuff that you need, like paging, sorting, filtering. You can even do inline editing if you need that. And the grid can simply create it like that. And you can even set the columns based on the property names of the class. That I regularly don't do. It's just for the slide here because it's much shorter. Usually I add each column separately. And here we see that a column can also contain components. That's the component renderer there. And here we have like a link for an edit. And the grid also has the possibility to reorder the columns. That's something that we use in our project. The user can change the order of the columns in the grid, and this is saved then in the database. And if he gets back to the page, then he has the same ordering as before. And if you use a component like a grid or also a combo box or a select where you have multiple elements, then you need something that binds the data to the component, and this is called data provider with Vaadin. And there are, in fact, two different data providers with some variants, but you have an in-memory data provider. You don't see that, it's just a method set items, but behind the scenes, a data provider or a list data provider is created, and this is in memory. So that's good for select components, for example, if you have 5, 10, 100 elements. But that's not something that we can use because we have some tables. There are millions of records inside, so that wouldn't be a great idea to load all the data in the memory. So that's why there is a lazy data provider. And the lazy data provider comes in different flavors. And here's one that we most of the time use. You can have two methods, or here we pass two lambdas. And the first one is to fetch the data, and the second one is to count the data. Why do we count the data? If you have a grid and you have a scroll bar, and if the grid knows how many elements are in the grid, then the scroll bar will stay at the same size, and it indicates how many you have. So if you have a lot of them, you have a small scroll bar. If you have just a few, you have a big scroll bar. You can you don't need to provide the count. Then Vaadin just guesses how many you could have, or has a default size, or you can set the size and you do the guess yourself. But then if you scroll, maybe the size of the scroll bar changes during scrolling. That's the point. So paging, by the way, is done by infinite scrolling and not with buttons and next and previous and so on. Now, the interesting thing about this method here, so it's just probably a CRUD repository from Spring Data, but the interesting thing is the query that we get. And the query has all the information that we need in the repository. So we have, if we have a filter, we have the value from a filter field, for example, or from many filter fields. We have the order by information, so the columns can be sortable, and you get the columns that were sorted, and you get an offset and limit. You need that to the page. And this can be, here I don't think that's it, that this is a Spring Data repository, because there you could create a page request and put and pass these things right away. And that's very handy, and that's you need really all the time. And it's not possible, in my opinion, to make it easier. The other thing that we need to create an application where we can enter data, we need some data binding with converters and validators, for example. And for that, Vaadin knows the concept of a binder. And with the binder, you bind an object to the elements in the form. And there you can have a converter. There are some pre-made converters like this string to integer converter, or we can have a validator. There are also already pre-made validators, and then you can do whatever you want. And finally, you bind getter and setter of the employee record in that case to the field. What you also have with Vaadin is push. So I already talked about bidirectional communication. Vaadin uses atmosphere, so that means if it's possible, then it tries to use WebSockets, and if not, then it has a fallback to long polling. And here you have a similar, if you remember Swing, and you have a thread started, you have to find the right thread to write to the UI. And here's not a thread, but it's the context. So you have to get the UI. For example, here I have a click listener with a Spring task executor where we can do some long-running stuff. For example, we generate PDF files. That takes a while. And so we display a progress bar to the user. And once it's finished, we say it's done. You can download the file. And then you go to the UI. And here with this access method, that's more or less the same idea. We like getting the right thread in Swing, and then you can send something to the user. That's quite handy. What's very interesting as well is testing. So Vaadin provides a test bench. Test bench is a product based on Selenium and WebDrivers. So this looks like this. So we can have a look at the code. Here we have the test, so it's a test bench test case. And here we set up the Chrome driver, so this will use Chrome. And then we say where it should get, so we define the address. And then we have selectors, looks like jQuery a bit, with this dollar, and then the element, and then we can something get by ID, or the first element, or the last, whatever we want. And then we can set the value, we can say click, and we can then check if the text in the label has the correct value. And if we run that, this will start a browser and do the tests. The problem with that approach is this takes a while. So if you are into test-driven development, that's probably not the way to go, because this is end-user testing. So that's test automation. It's very easy to do, by the way. We have a lot of tests. We also measure the test coverage based on the UI tests. We do unit tests for the business logic, but we don't have a lot because most of them is in the PLSQL code in the database. There we also do testing because there's a framework called UT-PLSQL, unit testing for PLSQL for people using Oracle databases. And we do the testing on that side. But there are two issues. First of all, that's not free. So Vaadin, most of the things in Vaadin is free. Vaadin has some components that are so-called pro components. They have some additional features, but I don't use them, by the way, because I think it's easier to build them yourself, so they're not that helpful. But there are other things like Vaadin built the collaboration engine lately, and there you can really collaboratively work on the UI. That means you have a server, and then you type in a text field, and this will reflect to any other that is using the same record, for example, in the application, and he immediately sees that someone else is typing. And the test bench is also not free. The problem is that Selenium does not work well with web components. I have no idea what the current state is, but this is one of the problems of Selenium currently. And that's why Vaadin created a test bench on top of Selenium to support the web components. But there is another project, it's called Caribou Testing. That's not directly from Vaadin, but as far as I know, they will integrate it into the Vaadin open source project because it's made by Martin Vishny, and Martin Vishny is a developer from Vaadin at the end. And what he did like mock MVC for Vaadin. So it simulates the Vaadin UI context in a mock environment, and you can use that as UI testing. And this could even be used as unit tests because it looks similar like the code here, just the difference that we have different selectors. And the Caribou test here, that's class that I made, and here you see we use the application context. We create a mock Spring servlet because Vaadin is also based on a servlet. And then this is set up and tear down. And here we have some stuff for Spring security. And when I run this test, this is much faster because it doesn't start a browser at the end. So we don't see a lot here. It's not much to see. But this is very handy and also helps to get a good test coverage, because usually the problem with web applications is that you don't have a good test coverage. That doesn't mean that's not possible, but if you think at Timely for JSF, that's a bit hard to get unit tests for the code there. Here, that's very easy because you have this mock environment that you can use. And finally, Vaadin is a single-page application. It also has this progressive web application support. So progressive web application support, or progressive web applications, is not a specification where you define a web app manifest, and then you can, for example, install the application on your local machine. That's why we have here this button, and I can say install it, and then Chrome removes the address bar, and it looks like kind of a native application. That's the idea of that. But this would also have some offline support. So you could do in service in the service.js service.js file, you could do something if you're offline, for example. Yeah, and now we have some time for jOOQ. Who does or who knows what jOOQ is? Not that many. You all do SQL, right? No. Who is using SQL databases? The majority. Okay. And how do you do that? JPA, Hibernate, MyBot, something like that, right? The problem is, if you do that approach, you cannot use the whole feature set of your database. So you're limited to what Hibernate has implemented, and that's it. For sure, you can create native queries, but then you have strings. I mean, it's better with text blocks now, but these are still strings. No one checks this. You have to write tests to check if your SQL statement is correct. And jOOQ does that for you. So jOOQ has two parts. First of all, it has a generator. We will see that in a minute. And it has a so-called domain-specific language. The domain-specific language is SQL, but SQL in Java. So what you do is you generate some meta model from the database. You can do that in various ways. For example, in my example, I use Flyway for database migration, and I use the Flyway scripts to generate this model. But you could use, and that's highly recommended these days, to use test containers. So you spin up your database with test containers, you apply the Flyway scripts, and then you generate the database structure here for jOOQ from the test container instance. We can do that because we have a lot of tables, and we don't have Flyway scripts, by the way. They have kind of a master database where they apply the changes. That's not very safe. I wouldn't recommend to do that. But we generate the jOOQ code from this reference database to get this. And I think about 8,000 classes are generated from the customer database, because jOOQ generates a class for every table, every view, every user-defined type, every procedure, every function, every package, whatever database type you're using. And the cool thing about that, you can use that later on to write code. So that's on the left-hand side, you see what's generated. And this is not very interesting. I skipped that, but that's jOOQ. So if you look at the statement here, the first one, we do select from employee fetch. And employee is something that jOOQ has generated. So I can only use tables or views that are there. So I could put in a string, but I wouldn't do that. Why should I use jOOQ then? But if I use jOOQ, I use this meta model. And for example, here on the right-hand side, you see an insert statement. And if someone changes the column name of the department name, then my code no longer compiles. So in contrast to using strings, you use a meta model, and that's type safe and compile checked. That's the advantage of jOOQ. And you can do a lot of different things. You can use all what you know from SQL. And the good thing is jOOQ is also simulating stuff. So if you want to change the database, you don't have to worry. Your code will probably run also on another database, because if some internal stuff of the database is a bit different, or joins are made a bit different, then this is what jOOQ internally does. And it has a lot of features. I don't have time to talk about that. Just something that's very handy is jOOQ also generates records. So for every, we see that here, for every table you get a record, like this employee record, for example. You also get records if you're doing projection, but then these are untyped or are typed records, but not named. So we have record 1, 2, 3, depending on how many columns you're using. But you can also fetch the data in like records, or in Java records, or DTOs, or entities at the end, if you like to, whatever you want. But these records implement kind of the active record pattern. That means they have methods. So you have a method store. Store does either an insert or an update, depending on the primary key. You can delete or refresh the data. So that's not a norm mapping. So it's not the same with, that you do with Hibernate, because with Hibernate you map all the database information to your entities. And here you don't have any dependencies. So with JP you also map many-to-many, one-to-many, one-to-one relationships. Here we have just a single record. And to show you that in the finally 10 minutes, let's go back to our application. Here we have a sign-in button, and I use some user, and then I see this employees grid where I can enter or change data, like here, and then this is saved in the database, and this now uses jOOQ. Now, why don't I use Hibernate for that? That's a good question, because I'm teaching at the university, and I'm teaching Hibernate and JPA for 15 years now, so I would say I know it quite well. The reason for that I don't use it is that it's not necessary. It depends on the type of the application. Maybe you were with Michael Blood about domain-driven design yesterday or today, and domain-driven design has the idea that you get a rich domain model. Many applications, for example, small applications. So you have I have a customer that's University in Bern as well, and they have a lot of management tools. So they manage like IP ranges, or they manage like students or something like that. And there's not a lot of domain logic usually. And for that, it's maybe easier to not do domain-driven design. And if you don't do the domain-driven design, you probably do data modeling, like we did 27 years ago, or like I did 27 years ago. And then you have a data model. And then you want to use the data model to display, to edit the data. And if you look at the applications, most of these applications look like this. So like the ERP system, you have a grid and we have a form. And here I don't need any dependencies, right? Because if I want to display data, and I do that, so I have data from an employee table and data from a department table, then I do a join, and then I get back like a projection. And that's what I want to display. I don't need the dependency from employee to department, and then maybe I have lazy loading and stuff. That's not necessary. And on the other hand, on the right-hand side, I also have just a record. So I have a flat structure. I don't need nested objects, and I don't need dependencies in the UI usually. So it's kind of how you deploy, or you work with your application. Just a hint, if you look at jOOQ, jOOQ has introduced multiset. Multiset means you can read nested data in one SQL query. That's much faster than what you do with Hibernate. You will never have this n+1 select problem with jOOQ. Nested is simulated behind the scenes, because this nested query or nested results is something that are discussing in the SQL standardization group, but it's not inside the SQL standard currently. But as jOOQ does, if you do such query, then it will use JSON functionality of the database to get nested results back. So you get the JSON structure, and then you have nested objects. You could even use the JSON to deliver it directly to the REST API. Okay, so that's how it works, or how it looks, and it's how it works. We will see here. So there's an employee view. One nice thing about using Java to develop UIs is that you can use inheritance. So first of all, you do component-based development, UI component-based development. That's why I have a view, a grid, and a form. So that's something that says something about my application. But I can extend, for example, the grid. And here I use a view. That's the V employee record. By the way, this is generated from this flyway migration. I think that's here, where I have a view and use the employee ID, the last name and the first name, plus a join to the department. So I have the department name. And so that's why I have an employee record. So my grid displays employee records. Here I add the columns. As you can see, I can sort it, set a header. And finally, here is how I use jOOQ directly from a data provider. So I have no repository here. So I don't say that you should do that. It depends on the type of the application. But for my case, I don't need a repository. Why? Because I can do it here. And how do I test it? I use Caribou testing. So I have test coverage also from the for the queries. So I don't need a separate repository just for the tests. And here we see the code that we've seen in the slides before. So I do a select from this employee view. Then I have a where condition, order by. There I have a method that converts the Vaadin query to a jOOQ order by clause. By the way, that's open source. That's a project that I've created. I added some Vaadin jOOQ integration stuff that's maybe useful. And then I have to offset the limit, and I return a stream. And the other one down, that's just for getting the count. That's how it works. And the form, on the other hand, that's also a class that is inheriting from form layout. Form layout is a special layout. So if we look at this here, now we can't see it because it has just one column, but it uses a flex model, and then it behaves also nicely if you are scaling the application. And here we have this binder. This time the employee record is used directly. So the employee record is the representation of the data of the employee table. And then we bind here the ID, the last name, the first name, and so on. We have a converter and a validator for the salary field. And finally, we set, if we get the employee, we set the employee on the binder. So that's does automatic update the employee record. So if I enter something in the employee text field, then it's getting reflected to the record. And finally, if I do a save, I can call validate on the field. So then the validation is executed. And finally, if this is okay, I use a transaction template here, attach the record to jOOQ, and I store, and that's it. So that's all the code that I need to create this form right here. Oops. So time is out, and to conclude, in my opinion, if you're a Java developer and you have to do full stack development and creating applications that are similar to what I've shown you, then it's perfect. So it's much easier, you are much faster, testing is there, you have a really great framework. jOOQ, I like jOOQ because I like to work with SQL. If you don't like SQL, maybe that's not the best choice, but it leads to better performing applications. because you avoid all the stuff, all the problems that you will get if you're using Hibernate. And finally, Vaadin and jOOQ works very well together because usually you don't need nested objects, and so you can directly bind the types from jOOQ to Vaadin. Yeah, that's it. Thank you very much.